And today I'm going to talk how to combine Python with other programming languages while we make amazing projects. We're going to create a process monitor, bioinformatic libraries, and more. But first, we need to understand why the people use Python and get used in Python. As you can see in the example, we have a hello world in Java and hello world in Python. It's more simple, the code in Python, and it's more faster. That is the reason because the users use Python. Python have a big community, so if you have a problem, a lot of people will help you, and it have a lot of libraries that make your life more easy. You don't need to implement everything from zero like in C. But Python is not perfect. As you can see in the table, we have Python in the mean position of memory consumption. That is not a problem and is not an advantage. It's in the last places of energy and time consumption, and that is a very big problem. You know, while more time take a program, more energy it will consume. And we can see in the first places is we have C, Rust, and C++. It's a good alternative to combine Python with it. But the performance is not the only reason to combine it with Python. We have other features in other programming languages. For example, we have TCO. TCO is a technique for optimize the recursion. And we can't use pointers in Python, but we can use it in C and C++. Other reason is to export frameworks from other programming languages. You know Spark born in Java, and some crazy people create a kind of bean from combine it with Python. And the name for it is PySpark. It's the same history with Qt and OpenCV. Other reason must be use other paradigms that we don't have in Python, for example, logical paradigm, or be forced to use one of them. In Python, we can mix all paradigms, but we are not forced like in Java. Java forces us to use object-oriented programming. By the way, do you know the best Python libraries have the backend in other programming language? For example, PyTorch, OpenCV, Scikit-learn, and TensorFlow, they have their backend in C++. NumPy have their backend in C, and Polars have their backend in Rust. But there is other libraries that they don't need to combine Python with other programming language, like is the case of Pydantic. Pydantic is used for structured data, but FastAPI, Django, and Flask, yes, while more performance is better, but why they don't do it? Because the network and operating system can lead to the users problems, creating a kind of bugs. And there is more than one method to combine Python with other programming languages. One of them is socket. Other one is creating an API, using the pipe operator, and writing and reading files. The problem of this is it's running in two processes. If one process fails, the other one will fail. So you're going to have a problem. Two processes mean more memory consumption and more energy consumption. There is another method that is just one process, that is foreign function interface. When we are talking about it, we need to talk about the calling conventions. This is a statement at low level that says how functions must be called. And if you're going to use it, ensure your code is big enough or is very slow enough to optimize it. I mean, if you create a hello world in other programming language and you pass it to Python, your program will be more slower. When we are talking about foreign function interface, this is very old, we need to talk about the error that they have with the history. One of them is how I can convert a Python integer very big to a fixed size integer of C. We're going to have a problem because the word flow, but the same problem is in C if you do that. So the solution was give two responsibility to the C. Other problem, how I can pass an object from a programming language to another one. The answer for this was no pass the data, use the reference of that object in memory. And other problem, what happens if I have programming languages, both of them with garbage collector, so who will be the responsible to clean the memory? The answer for this is the programming language who asks for the memory will be the programming language who will clean it. We have more than one framework for combined Python. We have in C3, C-type, CFFI. By the way, Mike is the core development of CPython. So you know C. Right now I'm going to pass to the project samples when we're going to start to addition two numbers to be familiarized with the framework. After that, we're going to make a project. We're going to start with Prolog because this is logical-oriented paradigm, so you can solve things that you can do in Python. In this case, we're going to start with the addition. For this, you need to have installed the other programming language in your machine and the framework of Python, in this case, PySwipe. And in this case, we're going to make a query inside math.pl, and in this case, will be returned more than one answer. This is not because the addition is bad designed, this is because Prolog is designed for it. We have another example. This problem is, hey, we have a chessboard 8 by 8, and we want to know how the horse moved there. This is not very easy to solve in Python because you can do it with a breadth first algorithm. If you're going to do that with matrix operation, you need to check the horse will be inside the matrix to don't get an error. In Prolog, you don't care about it, you define the mathematical operation for that. We're going to see another good application of Prolog. How you can say to Python, hey, solve this. Python can't. For this, we are making an automatic theorem prover. That is something that's going to prove you mathematical formulas for you. Here we have the Prolog code. We are defining the logical operators. We are using for one chain method for demonstration. We save the things that we tried in that list. And we are load or inference rules that are kind of logical structures. You can see one of them is modus spawning. You see our code in Python. In this class, I created it to handle the Prolog file. And here is when we access to the Prolog file, create the instantiate the functions, and here is the data that we take from the user from the website. I'm going to pass through the examples. In this example is a basic logical is Socrates is a human, and all humans are mortal. So Socrates is a mortal or not? Yes, he's mortal. But in the other example, I'm going to put it to fail. In this example, will be say, humans are Socrates, but it's not true. In the other example, I'm going to prove all numbers greater than 0 are naturals. You can do that only in Python, so you combine it with Clojure. For the next example, we're going to combine Python and C. Who here is a C programmer? Who knows C? Okay, a lot of people. For this case, we're going to make a sniffer, also known as network monitor. In this, we need to receive all the information from the network. We need to have a special configuration for our socket and the code information. After that, save or send frontend and plot it. The user operating system know, hey, someone can spy you with this, so you need to give the permission for this code to run it. This is an example of how we decode data. We split in binary in fixed size. I mean, from the bit 0 to 15, we're going to have destination port. And from the 16 to 31, we're going to have destination port. I'm going to show the code right now. We start with the C code. We don't need to import the library there because Python do it naturally. And here is when we have the configuration for our socket. If you see, we start with ethpl, that means, hey, we're going to receive all packages. And with AF package, mean we're going to work in the second layer of network. With socket raw, we are saying, hey, we want the data as raw. We load the things in a text-plain file because, as I said at the start, this is a bad example of how we can combine Python and another programming language. This kind of problem will have the same problem if a Zapier, a Django, and Flask will be combined with other programming language. You see the class when we handle that C code, the packet management, that when we format the text-plain file, we do it via socket because we need it in real time. And you see, we are reading in real time the text-plain file. I go into the web. You're going to see it. And I'm going to run it for 30 seconds. We see the most common IP is localhost because this program is sending a lot of packages. And other ones. And the packages that we see and more. The next project is with C++. Who here is a C++ programmer? Who knows C++? Okay, nice. In this, we need to include PyBind11 because it's our framework in C node, and we need to define what is PyBind11 module, so what will be a class in Python. We need to compile that with this compilation directive, and after that, call that in Python. Must be in the same folder. For this, we're going to make a process monitor. I'm talking a lot of times here, but what is a process? A process is a program that is running. Here we have an example of a process monitor called top. Here we have another process monitor that is htop, and this one is another one that is btop. The difference between this and the other one is it handles the process as a tree data structure, because a process can generate another process. And here we have the code. We start to defining, hey, we're going to import PyBind11. This is the data that we're going to take. Here is, you see that folder there is when the process or our computer, the programs are running. And we have some folders there. Inside that folder, we have each process. Each process will have this file, status, stat, and com. Inside that folder, we're going to obtain some data. And this is the class when we combine C++ with Python. We need to compile this C code with Python using setup install. And with that, we're going to access to the main file when we have the class with the handle for C code. You see we are using socket.io because it's in real time. We update this each 5 seconds, and we're going to our process. In this case, we want to test all data that we have is true. So when we get this number, we go into the folder where we have the process running. That process in that folder is proc. Here, all these numbers mean the process identification, and we're going to have the same numbers as process running in our computer. We're going to take the process ID 1 as example, and we're going to check the memory is true. Here, you see it's the same number, so it works. Now with Rust. With Rust, it's a little bit different because we need to create a project with Cargo. I want to know who here is a Rust programmer. Okay, a few people. Cargo is a project management tool that say, hey, how to create a Rust project. We created a project with it. We created a virtual environment with Python inside that Cargo project, and instead set up tools build and Maturin. Maturin is the other name for PyO3. And in this case, we need to define too what is a Python function, after that what is a Python module, and when we're going to call that. We need to have the Python code inside that folder and call it. You see here the import. And by the way, I always forgot that we need to specify, hey, we're going to use PyO3 inside the Cargo configuration file. For this project, we're going to make something easy. We're going to test Rust is more faster than Python for a simple function. I made it a bioinformatics library time ago, so we're going to use it. These are the shortcuts that I'm using. This is the bioinformatics library. You can download it with pip, and you see it's made with Rust, and we're going to take the first function, that is the Levenshtein distance. Levenshtein distance is an algorithm to see how many steps I need to take for convert from a string to another one. I'm going to install the library. This is to show you I don't have that installed in my machine, and make some tricks, so to show you you can download it from pip. Now I'm going to test the code. You see the code in Python take 25 nanoseconds, and the code in Rust take 4 nanoseconds. I'm going to use the same function with more arguments. You see the arguments. This is the implementation in Python of the Levenshtein distance. It's the same from Rust. And right now, the result in Rust is 200 times more faster than Python. 200 times more faster. That is a lot. For the project with JavaScript, we're going to make a 3D file system. What is a file system? When we have the folders and we can see it. This was a proof of concept when I don't like the answer because it's very difficult to move there. So it's just pretty. In this case, you see we have the same folder in the website and in the folder. We take this address to get the data, and we pass that data, is in the URL, to that function, host.listDir, and it's going to return me all the files that I have there. And I'm going to delete some hidden files there. So that is because I'm using this function. To pass that to JavaScript, I convert the data variable from Python to the data to JavaScript. Now Java. Who here is a Java programmer? Who know Java? Okay, nice. And see, hey, I didn't change the Python code. What is happening here? It's the same, but right now it's with the Scala. Who here is a Scala programmer? And we have the similar Python code with the same library, but with Clojure. Who here is a Clojure programmer? I am only with mental illness. Oh my God. And for this, we need to create the Clojure file, the Clojure project with Lane. Lane is the project management of Clojure. We need to compile it with Lane Uberjar, and we need to say the Clojure management tool, hey, we are changing the compilation extension from JIT to AOT, and define the main class that must be added. You see here with JPipe, we specify, hey, we are using Clojure, and for the project with Clojure, we're going to make a compiler. This compiler is for a specific kind of assembler that I take from a course called NAND to Tetris, and they teach you how to make a computer from zero, from logic gates. We have here two kinds of instructions, A instructions and C instructions. The alt symbol means it's an A instruction, so it's used to be a number that will be saved in the variable A. And the C instruction is more extensible. We need to convert that instruction into that bytes. We do that with this dictionary. So I am showing in the video how to convert the binary 010 means, hey, you're going to save it in a D variable. And they have other instructions, for example, com. Com means the computation. If we have the A bit in A, it means we're going to use this column. And if not, we're going to use the other column. We're going to make a binary conversion. The next project is a Java computer. I'm implementing the real computer from zero in Java. In this case, the register is here, so when we save the variables with D, and the A is here. For this, we need to implement the ALU, the arithmetic logical operation of the computer in Java. This is the conversion, it's mathematical operations and conditional no. And for the RAM, it's a simple array when we're going to save the data. And the ROM stands from read-only memory. We're going to use just a text plain file. This is our Python code. We have more than one classes, each for each component of the computer. You see here we have the ROM, and it's just a file. We send the data from Python to that file and overwrite it with new instructions. You see the RAM was just an array. This is the CPU when we handle the register and the jump instruction. By the way, a deep if and else and while and for work with jump instructions. They are not a functions. You see here it, and we're going to pass to the ALU, and you see the implementation of the code. It's the same. And now I'm going to show how the computer works step by step here. I'm going to take from the last project the binary, and I'm going to convert it. This code means, hey, I'm going to do addition of 2 plus 3, that's going to give me 5. I started loading that in the variable A, and after that I'm going to make this sum, and I'm going to have 5. I'm going to change 2 for 3, and it's going to give me 6. Basic arithmetic, so we have it. And it is the steps that we take for do that. But how is possible we can combine 3 or more, because we can combine Java, Scala, Clojure, Groovy, and Kotlin with the Java virtual machine with JPipe, because they compile inside bytecode. Bytecode is an intermediate programming language between assembler and the Java virtual machine. We handle the bytecode with JPipe, in this case, and it's born to solve the problem, hey, in the past we need to make a compiler for each operating system. For example, you have one compiler of C++ in your computer because you use Linux, and I have different because I'm using Linux. Java born to solve that problem. And we have a kind of example. We have the Java code here, we compile it into bytecode, and we're going to compile it after that in a programming language that understands our own machine. This bytecode is a kind of a stack automata programming language. It uses more than one stack, but it's just a curious fact. So I ended the talk, I near to the end. I was a little bit faster because we lost a little bit of time at the start, and we talked bad about Python and his bad performance in the Python, a little bit hilarious, and in the best way to combine two programming languages, when it's better to combine Python and when not, how Java, Clojure, and other programming language on the Java virtual machine works, and we do amazing stuff to create. Thanks a lot. You can check the code there in that repository. Thanks for all the people to help me to prepare the speak. And many questions.